Hi. I just wanted to talk a bit about the ARC Prize, which is a global contest for research in AGI, artificial general intelligence. So we had the founders of ARC Prize come in to USC a couple days back for as part of a university tour to talk about the competition, to talk about AGI in general, what's going on, what they so they want more people to be working on it, collaborating and putting their ideas together, thinking about AGI in general. Yeah, I just found it interesting. I was super engaged throughout the talk and just wanted to do kind of a recap of what I got to learn through this event and put down some details before I forget. It is pretty exciting. I mean, I've been exposed to AGI before this, but then never really got into it properly. So yeah, this it was pretty exciting to kind of know more about the stuff that's going on in AGI and what we're trying to head towards. So yeah, the ARC Prize, it is a $1 million public competition to beat and open source a solution to the ARC AGI benchmark, which is an AI benchmark that they have developed uh, to be able to, for the models to be able to generalize instead of memorizing. It's hosted by Mike Knoop, who is a co-founder of Zapier, and Francois Cholet, who is the creator of ArcAGI and also Keras, the deep learning library. Yeah, Franco Cholet is also, I mean, he has been awarded the Global AI Award for Breakthroughs in AI, and he's also the author of Deep Learning with Python. Yeah, and yeah, we had Mike Knoop come in to USC in person, and we had Franco Cholet meet us through Zoom. Yeah, it was nice to get to talk to these people, and so the ArcAGI benchmark. So most AI benchmarks measure the skill, but then skill is not intelligence. And general intelligence is the ability to efficiently acquire new skills. And so Francois Cholet's unbeaten 2019 abstraction and reasoning corpus for AGI is the only formal benchmark for AGI, and it is yet to be beaten by any model that people seem to be working on in AGI. So yeah, and it's easy for humans. So any average human would be able to solve. Even kids may be able to solve like 90%, and then any average person is going to be able to solve like 97%. There are 100 problems, so there are 100 random problems. Mm, so yeah, 97 is the average, and decently well, you're going to be able to do 99, 100 maybe. So it's very easy for humans, but it's hard for AI. And the ARC Prize, they intend to kind of open source the winning submissions, make AGI open source. And wait, so what's AGI? AGI, or artificial general intelligence, is like the hypothetical intelligence of a machine to understand or learn any intellectual task. So being able to understand what the task is and how to approach it, and kind of figure out the approach to solve any problem it's presented with instead of memorizing. So generalize and not memorize. So yeah, so they want more people to look at this problem, think about it, collaborate, and bring forward more solutions. They feel like it's the most pressing problem in AI of this time. And yeah, so this is kind of a graph on how we've been progressing on the other AI benchmarks lately since the introduction. So with scale, we are able to see that. So this is like the human capability, and we're able to reach that level with the other AI benchmarks, with the other models that have been that we have built, and just with scale. So like as the years progress, the compute power increases, the capabilities increase. So the model parameters increase. We've got like a billion parameters, more than a billion. Well, yeah. So we want. Mike was wondering. So Mike was talking about this, and he was wondering if scale is all we need. Um, do we Are we able to keep progressing with just scaling it up, just scaling up compute time, compute power? Would we be able to, hit any benchmark? Well, RKGI benchmark. Well, since it's been launched, there have been a lot of independent researchers working on AI, AGI. The progress has been slow. So we can see the I mean, the rate is not as high as the other AI benchmarks with scale. That is, so this is the years since benchmark introduction. So we're about like 4 years from 2020. So it was launched in 2020. And the ARC prize, the global contest, was kind of launched in June 2024 to get more people to work together. So that was when they were able to put together their independent ideas and collaborate. And we see a bit of a spike. They saw a 14% increase at this point after the contest was launched. But then it is still stalled. So so is scaling all we need? Probably not. We potentially need new ideas, new approaches to this. And yeah, that is what Mike was talking about. Let's see. So the ArcAGI benchmark itself, it is 100 random puzzles, something like this. So you have they give specific examples and the expected output, and the model should be able to figure out how to solve that. And I mean, any random average human should be able to kind of look at this and figure out what needs to be done. But then for a model to be able to generalize and be able to reproduce this result multiple times, that is kind of hard. And being able to identify what is needed is hard. But yeah, it is pretty simple. It's just based on core knowledge priors like linear algebra, pattern matching, finding and they don't want models to be able to memorize answers and instead being or even memorizing reasoning chains. They want to be able to synthesize these new approaches and identify. So I was just thinking, what could be a potential approach? This kind of looks like questions you would face in an aptitude test. And how would we approach that? How would we think about it? How are we able to solve it? So yeah, it's kind of like being able to identify relations. It's majorly being priorly exposed to it, right? So identifying relations to what we've experienced before and transferring approach. And I was thinking, is an LLM the only way to do this? Maybe there's other options as well. But that's that. And then they talked about efficient intelligence, being able to solve it while not giving it too much compute time. So they tested this model on GPT-4o or 1, Claude Sonnet. So all of these models, there's other contributors on Kaggle as well, who are higher than this. But then these models seems to provide different scores with different compute times, which begs the question: what's the limit on the compute time? Are we going to be so they gave an example of this submission on Kaggle. So this guy kind of just used GPT-4o. He's querying GPT-4o with the question and kind of generating 2,000 Python scripts, and then trying to figure out which one fits the problem, and then being able to fit that and then solve it. So he did that, and then he thought, why stop at 2,000? Go to 4,000, and then at one point you're going to be able to hit the benchmark, right? You're going to be 85%. That is the grand prize benchmark that they want to reach, and by the scale of time that the program took, it appeared that you had to generate about 100,000 Python scripts per question to be able to reach that point, which is insane, which is not scalable, which is not efficient, and we don't want that, right? Efficient intelligence is something we need to be considerate about. Moving on, these are the current high scores right now. That's mine's AI at 49%, and I think O1 Preview and Sonnet 3.5 were both at 21%. GPT-4o was at 9%. Gemini 1.5 was 8%. And the grand prize goal is 85%. Grand prize is $600,000. And they also have like smaller prizes for like publications in ArcAGI and any benchmark improvement. They don't think that we would be able to reach the grand prize this year. It's ending soon, I think November, but they're going to be doing it every year, maybe with higher prizes each year until it is hit. So right. And then we had Franco Chole talk about more technical stuff. So he talked about LLMs and how an LLM performance on a task is like purely a function of the task familiarity and not the task complexity. So it is not scaling with it is not LLMs are not scaling with the capability. They are, I mean, they are scaling with capability, but not as much as them scaling with the situations that they memorize. So there's still a lot of drawbacks to LLMs. I mean, he gives this example of, let's say there's this question: Alice has n brothers and m sisters. How many sisters does Alice's brother have? Now, the LLM is able to, like 4.0, is able to decode the question and solve it, but then the result varies with the range of m and n that we choose. And for some reason, the number of sisters also seems to affect the result sometimes, which is weird, which is not supposed to happen. And so going from a repo of memorized programs to being able to synthesize new programs on the fly. So that was fluid intelligence with the static skills. So static skills is just going to be memorizing programs and searching through that, or fluid intelligence is going to be how you're able to just look at a new problem, being able to identify an approach, and then synthesize a program on the fly. And he gave this kind of a transition of intelligence, like a flow, going from factoids. It's kind of like a lookup table, like just having methods to store what's 2 plus 2, what's 2 plus 3, what's 2 plus 4, right? And just looking it up each time you need it. So it does not have any parameters. And then you can potentially even have you can have a program, you can have a method to give you what's 2 plus x, and you just give x as the parameter. That's going to be kind of like organized knowledge. So you just know how 2 would get added onto this number. Still not good enough. And then we can generalize that, being able to add any two numbers irrespective of the parameters. That is more of an abstraction. And then we go to on-the-fly model synthesis. So given a problem, find the program that can solve this problem. And then more efficient and information efficient model synthesis is going to be given a few examples of inputs and expected outputs, be able to find the program to solve this problem. And that is what AGI is headed towards, on-the-fly model synthesis and efficient model synthesis. But current LLMs are almost just at organized knowledge stage. That's what Franco Cholet was talking about. And then we had he was talking about taking up a search-based approach, and right before that, abstraction. So converting information into models, so that is through abstraction. And he said that it's the process of looking at observation instances, noticing analogies, erasing variable details, and merging instances into reusable building blocks. And then he talked about type 1 and type 2 abstraction, which is value-centric and program-centric. So value-centric is being able to recognize features, cluster them together, abstract the details in the features, in the data, and clustering concrete samples into prototypes. For example, looking at a bunch of faces and being able to tell this is a face and this is not a face. And type 2 abstraction, program-centric, well, it's kind of like a graph of operators and operations, and being able to abstract with respect to the input values and input types, merging specialized functions under a new abstract signature. So that is type 2 abstraction. And then he talks about program synthesis, that is kind of being able to search through potential options and trying to synthesize the program that is needed to solve this problem. So he gave some values, like so basic heuristic search, which was the 2020 winner. It was able to achieve 19% on the benchmark. And then a refined heuristic search, 36%. And then the basic heuristic search scaled up, which was like an ensemble of all the submissions from 2020. It got a score of 49%, which is the state of the art right now. And then there's these are all program synthesis based kind of approaches. And then we have the LLM based approaches. So with direct prompting, we saw how O1 or Claude 3.5 was able to get like 21%. With the LLM driven discrete program search, so that was able to get 42%. And adding some more test time, fine-tuning, and other tricks, we were able to hit 49%, which was again the state of the art. And right, he also talks about how reasoning in humans is heavily guided by perception and intuition. For example, when you're playing chess, you don't chess. We're not going to be looking at all the possible options. We're not going to be looking at we're not going to search through all possible options and find the best one, right? We're just going to, like, given this current situation, we're just going to look at we just search over a small set of options and identify the best among that. And these options are determined by our intuition and what we see. And so we intuit where to go and then enumerate a small number of options. So yeah, so there is this situation of type 1 intelligence helping type 2, type 1 abstraction helping type 2, using the fast but maybe wrong judgment calls to keep the compute in check and being efficient about it, and searching among the potential options, right? So leveraging fast judgment calls to make the search tractable. And this is the approach that Tranquil feels would be the right direction, bringing type 1 and type 2 abstraction together through deep learning and program synthesis. And yeah, bridging type 1 and type 2, that was what he proposed would be the right direction. And he talks a bit more about it, how to actually implement that and maybe use deep learning to make it efficient. I'm not going to get into more detail right now, but yeah. So AGI would start with being able to search in an open-ended way, and yeah, just coming up with simple novel solutions, and then it could go to being more efficient and being more accurate. But yeah, that was what we discussed. Well, throughout this talk, I had the question, why? So why do we want to build such a model? What are we headed towards, and what do we intend to accomplish? Right, and I asked him on the Q&A, and that was actually answered as the last question. So Mike told about how, the current models, so any problem that we know about, the models that we have right now, they're able to solve it. And AGI, he feels, would be able to solve the problems that we don't know about, the unknown problems, and being able to adapt and solve on the fly. And this could lead to potential fundamental science breakthroughs and new knowledge, and it would be a way to search, imagine, and explore. I mean, yeah, it makes sense that you're able to kind of bring in the randomizing factor and generalizing factor into the AI. But yeah, I was just wondering, why do we need to be able to, why would we need such a model? Is the intention to kind of be able to do what a human does? Yeah, I was just thinking about that, and that's something to be thought about further. And overall, the presentation was super interesting. I feel like it could be something I would be working on. I would definitely be interested in reading more about all of this and seeing where it headed. So yeah, just wanted to kind of do that recap, put down my thoughts and what I kind of interpreted from the talk from them, and that's about it. All right, thank you.